Okay, this is the back of the function notation notes. So we're going to talk about functions versus non-functions, and it's something that you've probably seen from middle school. And it says a relation is information that can be represented by a set of ordered pairs. A relation can be represented in a variety of ways through a graph, mapping, table, or set of ordered pairs. Of the following relations, the first two are functions and the third is not a function. Why? So anytime we talk about a relation, we're talking about any set of ordered pairs. And they can be represented multiple ways. So these are all the different ways on your notes here that they can be represented. And every single set here is a relation. But some of the relations are functions, and then some of them are not functions, and we're going to talk about why. And so if you look for a pattern amongst the different tables here, you will notice that this one is not a function because the x values repeat. Okay, so it's not a function because the x value repeats. Over here on the function side, we have all different x values. -1, 0, 1, 2. Even though the y values repeat, like here the y value repeats, but that doesn't matter. When we talk about functions and non-functions, we only look at the x values. The next representation is ordered pairs. And again, these are the same ordered pairs from the table. They're just copied into a list. And anytime we write a list, we use brackets to represent that we have a list of numbers. And so this one is not a function because here I have a 2 and a 2. So 2 goes to -3 and 2 goes to 5. So again, it's not a function because the x value repeats. This next one is a mapping. And for some reason it did not print correctly. So this x and y should be up here at the top. And we're going to talk about these numbers. So 0 goes to 5. So if I were to write an ordered pair, that's what it would be, 0, 5. 1 goes to 6. 2 goes to 7. And -1 goes to 4. And all of the x values are different, so it's a function. Also, all the x values only have one arrow coming from them. Over here, I have -2 goes to 5. 0 goes to 6. 2 goes to 5. And 5 goes to 1. Again, these are a function. This is a function because the x values do not repeat. All of the x values only have one arrow coming from them. So when I get here, I have 0 goes to -1. 1 goes to 3. 2 goes to -3. And 2 goes to 5. Then there's one more ordered pair, 3 goes to 4. Okay, this is not a function because the x values repeat, or if I look at my x values over here, I have 2 arrows coming from the same x value. So this right here makes it not a function. All right, and then when we look at graphs, we use what is called a vertical line test, which says that a graph is a function when you can draw a vertical line anywhere on the graph, and each time it only touches one point. So I'm going to use this post-it note as my vertical line. This edge here is my vertical line. And as I drag it across the graph, I only touch one point. And if I keep going, I touch a different point, but I'm only touching one point at a time. And I touch another point and another point. So I've only, this vertical line, if I were to draw it on here, only touches one point at a time, so it's a function. If I come here, same thing applies. My vertical line, I touch one point, keep going, I touch one point again, one point again, one point again. So it's a function. And then when I get to this last one though, I touch one point, I touch one point, and now all of a sudden I'm touching 2 points when I draw that vertical line. So that means that this is not a function because the vertical line touches more than 1 point. Okay, so the definition of a function is a relation in which each input, which is your x value, is paired with exactly one output, which is your y value. Basically, a function is where x does not repeat.